Well, all right. I am back. I think. Briefly. Right? Okay. How's it looking? Let's see. Let's see. Let me edit my view a little bit if I can. Help you out some. There we go. All right. And that ring light is so bright. Oh my goodness. Okay. Oh, you know what? Let me set my timer. It's so helpful to have this timer, I tell you. All right. So 25 minutes, because we know we have about 29, right? So let me. Okay. All right. So we're going to do, was this visible? Let me check over here. Let me see just a wee bit. Yeah. All right. So when I left, it was time. The time was ending, all this good stuff. All right. I was working on the function, the composition of functions now, right? When we're putting g of x into f of x. So we put g of x into f of x. Sound like a plan? All right. So since we have to put g of x into f of x, we're going to find g of x first. And g of x is actually g of 2. So that's going to be, since this is g of x, we have 4 over 2 minus 1. 2 minus 1 is 1. 4 over 1, which is 4. Okay? So now we're going to take our 4 and plug it in to f of x. Okay? We ready? We know that f of 4 now, because that's what g of 2 is. We want to plug that into that. So we're going to take this, right? Because this of g of 2 is equal to 4. And since we're going to put that value, whatever g of 2 is, which is 4, into our f of x, the x is going to be g of, right? So now you're doing this part. So you want to know why they write it like that? Because you just did, now you did this. You did g of 2 inside, so you have f of g of 2. Right? Does that make a little bit more sense? That's why they write it like that. Because you're going to put this one inside this one and this one inside this one. Does that help? That's what you're doing. So now we're going to take it, since we know f of x is 2x plus 1, 2 times 4, minus 1. Minus 1, 2 times 4 is 8, minus 1, 7. Okay? So g of f of 2 is equal to 7. I know it seemed like it was going all over the place, but when you do it step by step, and like I said, we found this first. So we did not find f of 2. We found the f of g of 2, right? We found f of g of 2. Okay? Does that help a little bit? F of g of 2. The function of, it's easy to call it function when there's an f, but we found the function of 2 in the g function and plugged it into the f function. Want to do it again? Let's do it again. All right. This time we're going to use the same functions. Yes. We'll use the same function, but this time we'll make it f of negative 3. Okay? Is that what it? F of negative 3, is that what we're looking at? What do you want me to find? Oh, we're finding G of F. Okay. I had to look, y'all. I forgot where I was looking. So, this time, we're going to find G of F of 3. Okay? Hold on. Okay. Just teams. They can give me a minute. Alright, so if we're going to find G of F of 3, what does that mean? This time, the F is closer, right? There were so many things I used to remember this, but the one that stood out the most for me when I had this composition stuff, when I had to put one function inside the other, was whatever was closest to what I'm using. See, the F is over here. The first one we had the G over there. Now this time we have the F, so we're going to put the 3 in the F first. We're going to take that value and put it in the G. These first, and then that goes into here. So we're going to take our F of X, and we're going to say 2 because F of X was equal to 2X minus 1, right? And we need to find G of F. So then we're going to say 2 times 3 minus 1, 6 minus 1, that's 5. Now we're going to take this 5 to do G of F, right, of 3. So that means we're going to take this, that's going to equal 4 over, but this 5, is it 5? Or did I put it in wrong? Oh, wait. Oh, no, we're right, because our 2 is positive. I thought our 2 was negative. Okay, our 3 is positive. So, you know what? Let me do it negative too. Let me show you. So then, we got our F of X. Oh, 4 over 5 minus 1, right? So, that becomes 4 over 4. And what is 4 over 4? 1, right? So G of F of 3 is equal to 1. Okay? Teams, teams, teams. Y'all use Teams? It's crazy. Okay. All right. Does that help? Let's just say our 3 is negative. Let's do negative 3, right? So, if we had negative 3, would it be any different? No. Rules don't change, right? So I'm still, since it's G of F of negative 3, I'm going to put negative 3 into my F, and this is F. So 2, I know I almost wrote 3. 2 times negative 3 minus 1, negative 6 minus 1 is negative 7. Yes? And then so now we got negative 7 this time. So we're going to take it, we'll do 4 over negative 7 minus 1. Well, that turns into 4 over negative 8, which reduces to 1/2. 4 goes into 4 one time, 4 goes into 8 2 times. Alright? So, F of, is it F? No. G of F of negative 3 is equal to negative 1/2. Is that starting to make a little bit more sense? Starting to click a little bit? Let's see if I can find a good one. Okay. This one is going to test your knowledge and your skill of how well you remember the rules for fractions. Because I'm sure you'll get one of these and you'll be like, what? I don't know what? That's funky. No, it might look a little funky, but because we don't judge things on what they look like, we simply read our math like it says, and we just follow all the rules that come with whatever we're doing, right? We don't judge it on how it looks, so it's okay. It might look a little different in the beginning, but we got this. You ready? F of x is equal to 6 over x minus 3. That look at 6? Okay. And g of x is equal to 1 over x. And so first we're going to find, oh my God, why did I choose this? I tell you. F of g of x. F of g of x. Okay? All right. So g of x is what? G of x. G of x is equal to 1 over x. So we're going to put that inside here. Okay. So that means, because rules are rules. Rules are rules. I'm going to show you. Rules are rules. It doesn't matter what it looks like. Nothing to solve for this because g of x is simply 1 over x. We're going to put that in f of x, where g of x is. So 6 over 1 over x minus 3. Okay? What? No, calm down. It's okay. Fraction and fraction. What are our fraction rules? So we see. All we do is we look at this and we're like, wait, what? Don't panic. Don't panic. What is the rule for adding fractions? Adding or subtracting fractions. What is that rule? Because rules don't change. And yes, we have a complex fraction. Because we have a numerator and then our denominator is a fraction within itself. That makes it a complex fraction because it's a fraction inside a fraction. Right? So we're just going to take our denominator to the side and whip it up real quick. We're going to work with it. I'm going to whip it in the kitchen like some stir fry. Sorry, it just popped in my head. All right. So on the side, we got 1 over x minus 3, and we know it's 3 over 1. And again, the rule for adding and subtracting fractions says we got to have a common denominator. We don't have to know what x is. We just know that x is the denominator. So we're going to multiply by the common denominator, which is going to be 1x. So we're going to multiply this side by 1x over 1, and we multiply this side by 1x. Oh, yeah. Oh. I don't want to do it like that. It's going to get messy and ugly. I was like, don't do it like that. Basically, what is this missing? It's missing the x, right? So that means we have to multiply by x over x, right? Because it's in the form of 1. It's the same thing over here, but now this turns into 1 over x minus 3x over x, right? X over x is 1, just like we did before when we ended up with 4 over 4. Anything over itself is still 1, and that includes variables, because remember, variables are substituted in place of numbers, in place of the values. So just because we don't know what the value is, it doesn't mean that we make up a different rule. Rules don't change. That's why they're just variables, right? So now, and we also remember this rule, that if you have fractions with the same denominator, you can combine the numerator and keep the denominator, right? So this would then be A plus B over C. So again, if you don't remember a lot of these rules, hop back down to one of my first videos, because I think I made a video, I'm pretty sure I made a video going over all these fraction rules and stuff, right? So what is our new denominator, you ask? It is 1 minus 3x over x. Okay? That's our new denominator. Then we have to do some other funky algebra stuff to make it look right. So this, after we simplified, because we pulled this off to the side, right? We pulled this out to the side and worked on it. We didn't do anything different. We just pulled the denominator off to the works and worked on it so we can get a better looking denominator. Now we have 6 over 1 minus 3x over x. Right? It's still a complex fraction. Yes, I know. I know it's still a complex fraction. However, it's a little bit, it's less messy to work with because now we get to implement the rules for dividing fractions. And your rule for dividing fractions, right, is if you have, I'm just going to use the A over B. Well, can you see over here? I don't know if you can see over here. Your rule for dividing fractions says if you have A over B and it's divided by C over D, remember, you keep the first fraction the same, you change your division to multiplication, and you flip, use the reciprocal, of the second fraction. So dividing fractions means that you're actually doing that, right? So again, we're going to use that rule over here. That's why we keep all these rules. I always say don't try to calculate in your head. Don't be like, okay, -4 minus 3. Write that down and just calculate what's on the paper. You need to hold all these rules up in your head. You know what I'm saying? You can figure out the values of things. You can figure out the calculations as long as you take your time and you go step by step. The rules will help sort themselves out too, again, as long as you're going step by step so you don't confuse yourself. A lot of times you all confuse yourself because you're calculating in your head and you're not following with what you have on your paper, you know? So, make it a point, make it a practice, and this is what I tell you guys when I'm tutoring. Make your hands say what you're doing. Say, okay, now I am dividing fractions, so I'm going to take my numerator, which is 6, and we know that that's 6 over 1 times x over 1 minus 3x, right? If I say what I'm doing as I'm doing it, if I make my hand sync up with my mouth, I'm less likely to confuse myself so much because I'm at a steady enough pace where I can kind of keep my thoughts organized. I hope that makes a little bit more sense. So, we utilize this rule now, as we knew, and how do we multiply fractions? We multiply fractions straight across, numerator times numerator, denominator times denominator. Numerator times numerator gives us, I know I just threw it equals here. Numerator times numerator is 6x. Denominator times denominator, 1 times 1 minus 3x. Yes, you would technically FOIL. 1 times 1 is 1. 1 times -3x is minus 3x. Wow. Looks kind of crazy, didn't it? You're like, what? But no, it's doable, right? So this is what that's going to look like. These are your rules, your tools. Your rules are your tools. They're like directions, right? To recipes and stuff. You can't just, like, you can put some stuff together, but it doesn't necessarily always work, right? There's a system that we have to use to figure out. So let's see if we can find the other one. How much time? Dang, 6 minutes left? Okay. Don't make the mistake, so I'm not going to do it the other way. You practice the other way. You practice it and tell me if you get, Oh, well here, I'll show you in my little bitty 6 minutes. Let me see. Are we skipping anything else? Not yet. Let's just do it the other way. Got this? Okay. So now we're going to keep our same functions. When they leave me, I'll leave the tools up there for you. Well, I'm going to erase this set. I'll leave that for you. So now we're going to find, what did I say? We're going to find g of f of x. Now we're going to find g of f of x. And I hope you all realize, even if you have pretty much the same functions, just recognize that this will not equal. Okay? Does not equal. They do not. They do not. Okay? Keep that in mind. No. If you think, you're like, oh, but it'd be the same because if I distribute it says the same thing. No. Okay? All right. I know my time's winding down. Let me hurry up and do this one. Oh, yeah, we're done. G of f of x. All right. F of x is what? 6 over x minus 3. And so now we're going to find oh yeah, look, that's it. Now we're going to do this one, right? So now we have, if f of x is 6 over x minus 3, then we're going to put g of x where the x is. So 6 over 1 over x. Did we just do this one? No? Okay. 1 over x minus 3. But we have this situation again, right? So we have to break off to the side and work on our fractions. Let's see. 1 over x minus 3 over 1. That's going to be times x. So I got 1 over x minus 3x over x. I think we just did this one, didn't we? Am I doing it wrong? Oh, we did. I did it wrong, right? We already did this one. Because now we need, we need g of, my bad. We already did this one. We need to find g. Sorry, my bad. Sorry. Okay. Right, g. No, f of g. Which one are we finding, y'all? I'm running out of time. We already did f of g. Yes, we need g of f. Okay. So I was right then. Oh my god. F of x. My bad. 6 over 1 over x minus 3. Okay. So like I was working. Off to the side. 1 over x minus 3 over 1. Gotta find common denominator, right? So 1 over x minus 3x over x. So then I have 1 minus 3x over x. Right? I feel like I did this, y'all. Why do I feel like I already did this? Did I do it backwards? G of f of x. So I'm going to put f of x into g. Oh, stupid. F of x into g. Okay, that's what, I'm sorry. I'm rushing. Please don't hate me. I was like, I know I did this. Okay. F of x into g. Duh. The whole thing. G is 1 over x. So if I'm putting f of x into g, then I have 1 over 6 over x minus 3. There we go. My bad. I knew something was missing. I was like, hold on. Something's not clicking. Okay, but anyway, now that we have this, It's nowhere near as bad or complex as we thought. We don't have to do any fraction work pretty much, right? I mean, just a little bit of simple fraction work, because we know that this is our numerator, 1 is our numerator, and our denominator has to be that it's that complex fraction, right? So really we have 1 over 1 times x minus 3 over 6. Because what's the rule? Keep, change, and flip. Kept up the first, kept it, changed and flipped. So that becomes, that's what g of f of x is. Look, I need to stop trying to be so, that's what happens when you're running too fast, when you're rushing, you're going on fast, you're like, wait, you start mixing up stuff. But right, this is your, that was 25 minutes. All right, so that was 25 minutes. My camera's about to cut off in 4 minutes. So, I guess that's all the good stuff I have for now. Oh no, I'll find, oh, we need the difference quotient, don't we? That's what I need to work on, the difference quotient. Okay, I might be able to squeeze a difference quotient out. Maybe. Let me go see if I have another SD card, and if so, I might be able to do like a 10-15 for the difference quotient, just a little bit, all right? All right, see y'all in a minute.